Which one will have the actual y-intercept graph? Bottom. I agree. Because I'm looking at the y-intercept, x is equal to 0. This is the restriction that includes x equals 0. My slope of positive 1, I can either go up 1 and to the right 1, or I can go down 1 to the left 1. It doesn't matter because both of those locations will end up giving me an x-coordinate that is greater than or equal to negative 1. So with my straight edge, I want to draw only the portion of this line where my x-coordinates are greater than or equal to negative 1. Now I'm still going to start at the y-intercept for the top expression, but instead of plotting an ordered pair at 0, negative 2, I'm instead going to plot what? An open circle. I've got a slope of negative 2. If you go up 2 and to the left 1, what would your x-coordinate be? If I go up 2 to the left 1, x-coordinate would be negative 1. Because of that restriction on my domain, because I'm only supposed to draw this line if x is strictly less than negative 1, what kind of circle would I put? Open. So I've got 2 locations. It's not really 2 points, it's 2 locations. When I put my straight edge down, I'm only going to draw the line where my x-coordinates are less than negative 1. So Dylan, you can see this is the example where the graphs don't meet up. It's actually what we call discontinuous, right? A continuous graph means you can draw the entire thing without picking your pencil up. Here we've got discontinuity. We've got this break in our graph. Ends up being a big topic of discussion if you decide to take calculus. That 0, negative 2 is not going to be part of my picture. Even though I used it to draw my line, right, it would show my slope. I'm only going to leave that open circle at negative 1, 0. It shows me where that ray starts. Even though it's an open circle and it's not actually part of my function, it's showing me all of the points that are getting very, very close to x equals negative 1. You know, negative 1.000001. So are y'all going to tell me as the other two classes did, that this is no big deal? Because this is it. So my slope being negative, I always have options, but as long as that line is descending from left to right, that shows me a negative slope, right? If you didn't want to go down into the right, you can always go up into the left. That's still a negative slope. If you're talking about the arrow, right, that's based on the restriction on the domain. This tells me I'm only drawing the line with the negative slope if my x coordinates are less than -1. So that's -2, -3, -4, -5, -6. I would only have this graph when my x coordinates are getting smaller and smaller and smaller. So that means, yes, my arrow would be pointing to the top left, but my slope for that line would still be negative, because we read the graphs from left to right when we're talking about slope. Does that answer your question? You got to read the inequalities. So on the first expression, the -2x minus 2, that's when we had the open circle at 0, -2. We used a negative slope to get an open circle at -1, 0. How did we know they were going to be open circles? Because an x coordinate of -1 is not less than -1. -1 is not less than itself. When we had 0, -2, the x coordinate of 0 is not less than -1. So it doesn't meet this restriction, so it would be an open circle. Starting right there, I've now got an x coordinate that's less than -1. Here's an x coordinate that's less than -1. And here, and so on. All of these points would be x coordinates that are less than -1. Because of that extra if statement that they put in the question. You're not going to have to come up with this. They're going to tell you what the restrictions are. Finally, I'm getting at what I expected to be a very common question. This is what bothers everybody. My worry is no one else is asking. You're the first one in 3 classes to say, I'm not exactly sure why I'm only supposed to be graphing this part of the line. So thank you for asking. You had a question?
Could you explain why graph fixes these curves?
So, and I'm not saying you have to, but my suggestion is for you to always start where you get to put a point at the y-intercept, because that's what you've always done. Since Algebra 1, when you're drawing y equals mx plus b, you put a point on the y-intercept and go. Yes, we have 2 y-intercepts here, but I don't get to put a point at both of them. One will be a closed circle, a point. The other will be an open circle. My suggestion is to start with what's familiar. Start with the closed circle. How do you know which one? You look at the inequalities. If you're doing a y-intercept, the x-coordinate has to be 0. So 0 is only going to satisfy one of the 2 restrictions. It can't satisfy both. So that, to me, is a good place to start. It's a pseudo y-intercept, absolutely. You use it to draw it, but then you get rid of it. You gonna try one more? We have about 10 minutes. We should be able to. What's that? If you take my advice and you start your graph where the y-intercept is going to actually be a point, so are you going to use the first expression or the second?